Hi scholars, today we're going to look more into equations and decide when an equation has a true statement and when it would be a false statement based on what you put in the variable location. And before we do that, let's make sure we learn about some vocabulary and what it means when looking into equations. So let's read this together. An equation can be true or false. An example of a true equation is 7 plus 1 equals 4 times 2. And that's because this just means 7 plus 1, 8, equals 4 times 2, 8. That's true. An example of a false equation is 7 plus 1 equals 9. Because we see here, if 7 plus 1 equals 9, it's saying that 8 equals 9, which is not true. So know that equations can be true or false, but we have to decide on that based on what we know about our number sense. So an equation can also have a letter in it. For example, u plus 1 equals 8. And thinking about what u could be, we know that u should be 7 when we see this equation because we know that 7 plus 1 equals 8. But there are other values I can put in for u that would make it not make it true. For example, this equation is false if u is 3 because 3 plus 1 does not equal 8. And the equation is true if u is 7 because 7 plus 1 equals 8. Now we have some important vocabulary to think about. A letter in an equation is called a variable. So in u plus 1 equals 8, the variable is u. A number that can be used in place of the variable that makes the equation true is called a solution to the equation. And u plus 1 equals 8, the solution is 7. So those are two keywords. A variable is the letter in an equation. A solution is a number that can be put into the variable that makes it true. Keyword being true. When a number is written next to a variable, the number and the variable are being multiplied. Extremely important. So if you see something like this, 7x, this stands for multiplication. For example, 7x equals 21 means the same thing as 7.x equals 21. They both are the same thing. A number written next to a variable is called a coefficient. And if no coefficient is written, for example, in the equation p plus 3 equals 5, the coefficient of p is 1. Okay? So thinking about that, let's now move forward to the bottom part. I think here it should say if no coefficient is written, the coefficient is 1. I think it got cut off. Alright, but let's go to some examples here where we're going to explore some situations and think about what equation can I write to represent each situation. And I'm going to work for you number 1 and 2, and you'll try number 3 on your own. And I'm going to go over some steps. We're going to interpret the story first and write a verbal statement for the equation, draw a diagram, and then write the equation for the diagram. So for example, after Elena ran 5 miles on Friday, she had run a total of 20 miles for the week. She ran X miles before Friday. So what I'm seeing here is that there's a week and she runs 5 on Friday and X before Friday. So therefore, she runs X plus 5 miles for a total of 20 miles. So thinking how I want to draw that, I can see that I have a diagram where there's a total of 20 miles and she runs X miles on before Friday, and then 5, I'm going to redraw this diagram a little bit. I'm going to say that there's 5 miles on Friday and an X for the other parts of the week before Friday. So therefore, I can write an equation that shows 5 plus the X miles before Friday equals a total of 20. And here's my equation here. So I'm writing my equation after interpreting what's being said in a verbal form, drawing a diagram for it, and then writing the equation. Let's try one more together. Number 2 says, Andre's school has 20 clubs, and that is 5 times as many as his cousin's school. And his cousin's school has X clubs. So thinking about this, I have to think to myself, Andre's school has 20, and this 20 is 5 times as many as his cousin's school, and his cousin's school has X clubs. So what I'm thinking is 5 groups of his cousin's school's clubs, which is X, of X clubs equals 20 clubs. So 5 X's equals 20. So I'm going to draw a diagram again. And this is a total of 20 clubs. And what we're saying is that the 20 clubs is 5 times as many as the X's. So there should be 5 X's in my diagram. So if I was going to write an equation for this, I'm going to write down 5 times X equals 20. And I know that I can write it with a raised dot, or just write the number next to the variable in an equation form. So you have 2 examples here. I want you now to try number 3 on your own by reading it, writing a verbal statement, drawing a diagram, and writing the equation. Pause here so you have some time to think about this, and then continue when you are done with number 3. Here is the written statement for this question, and then the diagram and the equations. This one's a little tricky, so be careful. You have 5 cups of food divided for 20 cats, and that gives you X cups of food. So you have to have a bar that's equal to 5 cups, and dividing it into 20 pieces for the 20 cats. So you have 2 ways to write this solution. You can write 5 divided by 20 gives you X, or 20 groups of X give you 5. So once you have clarified any questions you have for this diagram, let's now move on to some practice below. So we have some equations here. We're going to just practice thinking about in our heads what numbers should go in the variable place to make it a true statement. So I'm going to model this for you, and I'm going to have you work on these after I model a few with your partners in your class or with your teammates, and then we're going to go over them as a group. So I'm going to model for you the left column, and you'll do the right column with your teammates. So when you're doing equations like this, you want to ask yourself, what can I do? What number should go in that spot to make that a true statement? So for example, this says here 1000 minus a, which is some number, equals 400. So we have to ask ourselves, what can I put there to make that a true statement? So thinking to myself, I have to subtract probably something that would give me 400, and I'm going to guess that I could put a 600 here to make that true. And that would be true because 1000 minus 600 gives me 400. So I'm going to say that the solution here is going to be A equals 600. So it's going to be some mental math thinking what would go there to make that a true statement. Same for the second one here. This is saying 8c equals 8, or 8 times c equals 8. So it's asking us 8 times what number gives me 8. Well, I see that it's the same number, and I know that multiplying by 1 gives me the same value. So I think a 1 here would make sense, which is true. So I'm going to say that C here equals 1. And then the last one on the bottom left, it's saying 99 hundredths equals 1 minus some value g. So I have to ask myself, 1 minus what value gives me 99 hundredths? So I'm going to think of money. If I have 99 cents equals $1 minus something, and I know that if I have $1 and take away a penny, I'm going to have 99 cents. So therefore, I think here should be a penny, which is 1/100th. Therefore, I can conclude that G equals 1/100th. So using that reasoning, try the right side. Pause here so you have some time to work on the right side. And then when you are confident in your answers, you can check it when the video continues. Here are your solutions. The top right should say 8 5/10 plus 4 1/10 gives you 12 6/10. The second one should say 1/10 for E because 10 times 1/10, which means dividing by 10, will give you 1. And then on the bottom right, 4/7 plus 3/7 gives you 7/7, which equals a whole, which is a value of 1. Once you have completed your notes, you can now take your X ticket for this class at the end of the class.